Folks, I'm Craig Wetmore. I'm the president of the York Flashings. I love flashings. I do. No, it's just, it's a thing. I have to go around the country and find people who actually want to listen to flashings. My team calls me the flashing geek. I like this stuff. So let's have some fun with this today. I've pretty much installed every type of flashing there is. I've smelt pretty much every type of flashing there is. I'm not joking. You have to smell the flashing to really understand it. So ask questions. We have to get this stuff right. So this is an HSW course, a GBCI CMP. So let's have some fun. Please ask questions. A few things just real quickly about me. I'm from Maine. So if I say anything that sounds funny, it's just what it is. Yeah, it's like pookie. Pookie's a technical term for sealant. So if I say pookie a lot, that's sealant. My grandfather was a builder. My dad was a builder. My brother-in-law is a builder. My brother owns the family lumberyard. Being French, my father said to me when I went to leave for college, he goes, "You understand we're French, right?" I'm like, "What does that mean?" He goes, "That means your older brother gets a lumberyard and you get to leave." This being French is not all that it's cracked up to be. So I'll mention my dad quite a few times through the presentation just because of what I learned being a contractor's son. And so I'm going to start off with the learning objectives, but before I do that, go into this knowing that I pretty much make every type of flashing we're going to talk about. I want you to understand them. Because if we don't understand them, we're going to put the wrong types of flashings in the wrong types of buildings. Let's get this right. Because there's no such thing as a bad flashing. And there's some people in the crowd go, nope, there's some bad flashings out there. There are no such things as bad flashings. It's just bad applications. You can't put a flashing that's going to last 10 years into a building that the wall's going to be up for 100. We got to match this stuff up and do it right. So what do we want to learn? All right, we have to look at what we're going to specify, but let's understand the attributes. We have to understand what each flashing does. Then let's understand compatibility. Brian, you touched on compatibility earlier. Compatibility is a really big deal nowadays. We have to get this right. And flashing is one of the many components in a wall system. And then how to design a resilient flashing system that will minimize life cycle costs. I had to look back and read it. Why? Because one of my younger associates at my firm, they wrote that. They got that out of the flashing should last as long as the wall. It sounds much better, but same premise. We want to make sure that we pick the right materials for the buildings. Brian went over the Zerk thing earlier. So Wish Jenny, Dan Lemieux from Wish Jenny gave a great presentation a few years ago, and he stated that 80% of all construction-related claims are because of water. So what do our building owners know? I know if I'm buying a building, it should not fall down. We're all clear? We all agree they shouldn't fall down, and they shouldn't leak. I know they're not supposed to leak. We could dislike the carpet or the paint or the ceiling tile, but if it leaks, you have a really good chance of going to court. If an 8 out of 10 chance that if you go to court it's because of water, we got to get this right. We got to get it right on the first pass. Everybody here, being at the BEC, everybody familiar with Dr. Joe? Dr. Joe Stiebrick gives the blue rated R building science course. Dr. Joe always says WAVT, 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 right? Water, air, vapor, thermal. Nobody has ever called you in the middle of the night going, "Oh my God, my building's leaking air," right? But if it's leaking water, you're going to get the call. We have to get water right. If we don't get water right, nothing else matters. It doesn't matter that you have an energy efficient building if everything's rotting. So we have to get water right, and hopefully that's what we're going to do today. So my grandfather used to say, we need the big tick walls, the tick walls. We're French, right? There's no H's. So we need the big tick walls. He wanted the mass masonry walls. Cool, stone, brick, all that sort of stuff. Why? Because they're big, thick walls. It would rain, they would get wet on the outside, but eventually it stops raining. They would dry out. In the late 1800s, the 1890s, we came up with Rainscreen walls. They did not catch on. It took till after World War II for them to catch on. Anybody here I think this is a student section, right? Anybody here ever ask your parents why there were little bricks on the outside of the school and big bricks on the inside? No? My mother could have used Google. I asked the stupidest questions, but I couldn't figure it out. Like, outside of the school has these little bricks, the inside had CMU. So as a kid, I couldn't figure that out. But what we were doing is we had our block backup and brick on that particular building. That's how we build nowadays, rain screens. Doesn't matter what the cladding is, we're building an airspace to let the water run down. And at the bottom of the airspace, we have a flashing to catch the water and exhaust the water. I know this sounds really simple right now. Flashing's a water shedding device. Yeah, there's a bunch of people who know that there's something coming behind this a little later in the presentation. We're not supposed to be building pond liners. We're not supposed to be collecting water. We're supposed to be exhausting water. And that's a really big part of flashings because sometimes we get it 90% right. So we're going to talk about Rainscreen Walls today. Who here played with a Rubik's Cube as a kid? Anyone finish without cheating? Anyone? Really? Oh, bless. That's awesome. I always love it when there's a bunch of engineers in the crowd. Yep, peeled off all the stickers and yeah, pop the pieces off. Our cavity walls, when I worked for my dad, we had damp proofing, a little bit of flashing. It's pretty simple. It wasn't that hard to figure it all out. You felt terrible being the guy doing the damp proofing. I was always waiting for the people to come with feathers and throw it on me because it was full of tar, you know. But nowadays, we have air barriers. Air barriers are the best things that ever happened to flashings. Because when I grew up, one of my dad's foremen said, "Kid, go to the store, get the 4.5-inch hole saw." I'm like, why a 4.5-inch hole saw? He goes, because every pipe fits through a 4.5-inch hole. You laugh. X the type of the air barrier. Almost said it. Exit the house wrap, put it right over it, and you have a 4.5-inch hole with a 1.5-inch pipe going through it, and nothing sealing it up. So as a flashing guy, oh, the building's leaking. Well, could it be the 4.5-inch hole that we that we didn't take care of? No, it has to be the flashing, of course. So we go through everything. Air barriers, we're sealing all this stuff up. It's fantastic, but we have to make sure everything plays well together. So air barriers, they're here to stay. Transition membranes, all over the walls, right? Roof to wall, wall to foundation, windows and doors. And there's tons of different types of transition membranes. We have to make sure they're compatible. Think of each material as a side of the Rubik's Cube. So then we have sealants. Lots of Tremco folks here. There's a lot of different sealants, right? And everyone's a little different. And we need to seal all these things together. Then we have insulation. Well, we're trying to control the dew point. Right? What was it? We don't eat our sweaters. Yeah. So insulations, we're controlling the dew point. There's a bunch of different types of insulations out. All of these things have to play well together. And then, of course, we have flashings. So when we write our specs, we have to make sure everything goes together and that they're compatible. If they're not compatible, those darn lawyers start showing up. And it's pretty easy to say, oh, well, you used this sealant, should have used that one, this, that. Hey, Monday morning quarterback, right? You can get in there and, hey, this is what happened. Brian, does your team have a chemist on staff?
A couple of them.
Yeah. We have testing people. The architects in the group, do you guys have staff chemists? No, seriously, it's a fair question, right? You don't. That's why the manufacturers have to partner with you. We have to be good to you. We have to share what we know. And if we're not sure, we test. Why? The lawyers have enough money. We don't want to give them any more work than they already have. We have to get compatibility right. We live in a very litigious society. We have to get this stuff right. The Air Barrier Association, I know Brian showed this earlier, but I was on the Flashings and Terminations Committee. There were 17 of us working on this. There's some really good work being done by the Air Barrier Association. If anybody wants to join, the more hands make easier lifting. But there's a lot of stuff, and if you're not sure, call. We would love to help. And if your manufacturer, somebody asked earlier, what if the manufacturer won't write a letter? Then don't use them. Or what if my brother-in-law Thanksgiving's really tough at my house. We have a few bourbons, we get talking. And we talk business, it gets ugly. So my brother-in-law likes to give at least 2 or 3 days when he asks for a VE before the bid date. You know, lots of time for everybody to work on it. But he has a lot of stuff going too, right? If we're worried about compatibility, make sure he gets the letter of compatibility for you with all the products. I know Brian said the top one always has to write it. I like mutual letters of compatibility. Mutual letters. Make sure it's tested from both sides. Make sure it's good. Manufacturers should work together. Flashing locations. Lots of spots where flashing goes in the building. Oh, the IMI. Is there anyone from the IMI here? The IMI does some great work. If you're looking at brick details, that sort of stuff, they're a go-to source, a great resource. So, what do you want out of your flashings? And I know a bunch of you are probably saying, flashings, how hard can this be? I loved it when I first started. The guy goes, you're the little line at the bottom of the drawing, right? Yeah, we are. We're the little line at the bottom of the drawing. We're responsible for getting that water out of the building. So what do we want out of our flashings? I'm going to quote the IMI, the Masonry Institute of Michigan, Masonry Advisory Council. There's a lot of great resources that we use. But this one's from the Masonry Advisory Council. So this morning when you woke up and you went, yes, it's flashing day, right? I have to listen to a day of air barriers to get to the flashing, but it happens. You paid the price listening to Brian to get to this presentation. There we go. That's going to come back to haunt me. But you all knew that flashing should be water impervious, right? Everybody got that? Yeah, it shouldn't let water leak through it. Till you go to New Mexico, Arizona, Southern California, they use paper. Seriously, paper. You know the thing that molds grow, the food source for mold? They use, it's not that wet here in San Diego. I don't know, I was in San Diego, it rained 3 days straight. My nephews are like, Uncle Craig, this never happens. I'm like, the only time I go to San Diego, it rains. So we can't use things that are water impervious. We have to use flashings that are water impervious. My dad stated something very clearly to me when I was a young man, when I first went into this business. He goes, kid, you're not that smart. We have a loving family, but he's brutally honest. He goes, you're not that smart. He goes, go listen to the people who are working with it. Go learn from the field. Nobody ever wanted to use a crappy building material. We work with the best stuff we have available, but we can only work with what we have available. So, went in the field for 7 years, a week a year in the field. I made a lot of my team do the same thing. Learned it's really rough out there. The fast track construction, there's a lot of stuff going on. We have to protect our flashings. The stronger they are, the better puncture and tear resistance they have, the more likely there will not be a hole in it when you go to close your wall in. Never really thought about UV, but excuse me, student section, we remember the 70s, right? There's a lot of us who remember the 70s. Matt, do you remember this? No, not really? Okay, back in the 70s, our cars had fading paint, cracking dashboards, cracking seats. UV will really wreak havoc on certain flashings, certain materials. So UV, there's some flashings we have to be very, very careful with how long we leave them exposed. Burns, I never really thought about burns until I went to this project up in Vermont. And this guy's welding a structural steel deck, so the sparks are coming off, and I have my phone out, right, the geeky, taking pictures. And we get up there, and the flashing has holes burnt through it. Looked like Swiss cheese. Burned the holes through it. And I know some people are giggling and laughing. If anybody's a fan of NFPA 285, go to YouTube, watch Lincoln High School fire in Lincoln, Michigan. Guy's down there and he's welding. There's a guy two guys up in a lift. And the spark lands on the through-wall flashing. The through-wall flashing catches on fire. Within 3 minutes, 2 sides of the building, all the way to the top of the building, are completely engulfed in flames. Does anyone know who went to Lincoln High School in Michigan? No M&M fans here? Is he too old? Sorry. So Burns are dangerous. Does everyone here agree that your flashing should not make your building ugly? Yep, flashing should not make your building ugly. Your flashing should play well with others. We don't want to get the lawyers involved. Flashing should play well with others. Who here enjoys replacing flashing? And there we go.
Restoration contractor.
Restoration contractor. Do you like replacing flashing that you installed?
No.
No. Okay, so nobody likes replacing flashing unless it's from an old building. Does everyone agree that your flashing should probably last as long as the wall? We're good with that?
Good idea.
How much does it cost to replace 1 lineal foot of flashing in a brick wall? At ground level, we're right here. We're replacing flashing right here. $250? National average is $300 to $400 a foot on the ground. And I had a guy come up to me one time who's a restoration guy, and he goes, if you don't stop, and he used a few words, and I'm okay with them, I use them back. He goes, Craig, that's at ground level. Go downtown Cleveland on a busy street, scaffold the sidewalk off, and go up 20 stories. I'm like, well, how do we convey that cost? He goes, tell them to multiply it by the floor level. And by the way, we don't replace flashing just at the spot we think the leak is. We replace it around the whole dang building, right? See the T's? Brian, where's the green thing? There we go. So they take the brick out, they jack it up, and then they go to replace the flashing. I like hanging out. Any forensic engineers in the group? Fantastic. I love hanging out with forensic engineers. They're usually very friendly folks. Well, I'm not saying you guys don't have friends. Yep. So I hang out with a lot of folks and learn from them because they're the Sherlock Holmes of our industry. They're going in and figuring out what happened, what went wrong, and how do we fix it. So I got invited down to Alpharetta, Georgia. Building very similar to this. It was a 4-story office building. You know the one you see off of every highway in every county in America? Ribbon windows, brick. The guy goes, Craig, the owner just bought the building as a distressed building. Building's 11 years old. The original owner gave up on it. He goes, I'm trying to convince him to do this right, but he doesn't want to listen to me, so would you come in as backup? I'm like, okay. So, and he shows me the details, and they weren't bringing the flashing out to the leading edge of the exterior. So they were holding it halfway on the bricks, so water was just running right back down the brick course. I'm like, you can't do that. So we went into it, and the owner goes, it costs $350,000 to fix this 4-story average size office building. To do it the way we were prescribing would have added probably somewhere between $50,000 and $75,000 to that. Does anyone want to guess how much the dollar cost of the original flashing? And there was flashing in there, and it was half an inch away from being right. Any guess? $1,868. We ruined a building. We ruined a building. Now, I didn't do the time value of money thing, right? Stuff costs less than it does now. But we ruined a building. We had an owner give up on it because we didn't do the flashings right. And we didn't do the corners and end dams. And there was a whole bunch of stuff. They were details. What I'm just trying to drive across, this is not a maintenance item. We cannot get back in this wall to fix this. Air barriers are not maintenance items. When you go to Charleston, South Carolina, they go, we skinned it. I'm like, you did what? We skinned it. We skinned the building. We took everything down. Oof. Feel like a red fox. Sanford, it's oof. So, Elizabeth, big one. Big one's coming, Elizabeth. So, does everyone agree we have to get this right first pass? All right, let's have some, and here's another great chart of let's fix it while it's on the job site instead of waiting until it's buried behind the wall because it costs a lot less to do it that way. So Thru-Wall flashings, there's a bunch of different types. There's the plastics, there's self-adhesive rubberized asphalts. I'm just going to call them peel and sticks for everybody. EPDM, does anyone use EPDM because we can talk about it, but I don't want to talk about something that nobody uses, okay? It's not popular in this area. PVC key, there's little pockets around the country, but really, I don't think it's this area. Anyone big PVC key fans? Nope, good. Got a bunch of slides out of the way right there. Flexible metals and rigid sheet metals. So PVC flashings. PVCs, if you ever see a manufacturer on a job site smelling the flashing, is one of many things. There could be something wrong with us. But what we're looking at, what we're trying to tell, is do we smell plastic? Anybody ever open a, kid opens a Happy Meal toy in the car and you go, whoo, that's plasticky. I don't think that's a word, but that's the one I'm using. It smells like plastic. If you can smell plasticizers, those can flash off. What this is, it's all recycled material, so it's great on the green community. We take binder covers, swimming pool liners, shower curtains, that sort of stuff, pour it in a vat, put carbon black in it, so it's all one color. We roll it out, and you have a flashing. And you have a very inexpensive flashing. But those plasticizers, as they flash off, this becomes brittle. And what happens when it becomes brittle? You live in a freeze-thaw area, and it all cracks. In the 60s, 70s, and 80s, this ruled the roost. This was everywhere. Mass failures, everywhere. The IMI, this is the only flashing that they talk about and say, do not use this. Why do I bring this up to this crowd? You folks obviously build great buildings. This is in every masonry house in the country. Hey, can I take this and VE this in for it? I want you to understand what this flashing is. This is good for 10-year buildings. Does anyone here build 10-year buildings on purpose? Anyone? Do we say, hey, let's just build it for 10 and then let's tear it down? No, right? So remember I said all flashings are good flashings? This is better than nothing. I'm not picking on Jackson, Mississippi. Well, when they said flashing, what's that? I'm like, oh dear God, here's some PVC. We need to get them using something. So very inexpensive, but I want you to understand it because people try to value engineer this into jobs.
What does your manufactured product say on it?
Our role actually says please do not use as a flashing. Sold 17 million square feet of it last year. We do not want to sell it. We want people to fight against it, but every big home builder uses this because it's dirt cheap. And unfortunately, it's going to cause a lot of issues. Any questions on PVC? Peel and stick. Who here watches how it's made? I'm not saying you're, hey, awesome, I'm with my peeps. There's so many times there's like not one person in the crowd who will admit to watching the show. I love to know how things go together. So when you look at this product, it really helps the understanding of what this product's capable of is to see how it goes together. So we have a facer. And that facer is a cross-laminated, we take 2 sheets of polyethylene, we glue them together in a cross-directional fashion. That makes it tougher to tear. Makes it a stronger product. That's what we want out of it. The facer is normally 4 mils. There's a couple people at 5 mils. Then you have some of the higher end brands that are at 8 mils. The US $1 bill is 5 mils thick. I gave this presentation, I've given it for a long time. 4 mils, 8 mils. I don't know what the hell a mil is, right? But the US $1 bill is 5 mils thick. So about the thickness of a dollar bill. That's your protection to the world. Then what we have underneath it is SBS modifier or APP. To dumb it down, sticky stuff. All right, so we have sticky stuff sticking the polyethylene to the asphalt. So when I started, I asked the mill manager, I'm like, well, isn't asphalt sticky? Because when you walk on the road, do you stick to it? I'm like, no, I don't stick to the road when I walk on it. So then we put sticky stuff on the back, the SBS modifier. Then we have a release liner. The release liner is paper or poly, and one side's dull, and the inside is shiny. The shiny stuff's silicone, because it doesn't stick to silicone. And if you ever want to know the magic of how all this is done, 20 mils thick. right? What we do is we have just a little bit of asphalt, 20 mils thick. That's window and door tape. Thru-Wall flashing has to be 40 mils thick. So what do? We just put more asphalt. Below grade waterproofing, 60 mils thick, more asphalt. Same facer, same product, just different applications of where we put it. So I promise this all comes together in just a second. We want your products to win, right? So the first thing we need to know, you cannot span a gap. Brian talked about it earlier around windows, right? We're trying to span a 1/2 inch gap. Every manufacturer says cannot span a gap of greater than 1/4 of an inch. Am I super duper worried about a 1/2 inch gap around a window? Well, if it's in the manufacturer's directions, yeah. But where am I really worried about it? You have a piece of flashing. It's on a brick. It's going through a cavity wall, right? Say it's up on the 2nd story, or it's at a, in a position where it has to cross the air cavity. Air cavities, how thick, folks? How wide? We always recommend 2, absolute minimum's 1. So it's going to span 2 inches. Now that's quite a span now. Do we think it can span 2 inches? Well, 4 or 5 mils of polyethylene holding up 35 mils of asphalt. Oh, hold on, let's have some fun. Let's throw some mortar deflection netting on top of it, and let's drop a bunch of mortar on it. Okay, now we're saying, oh no, we're not done. Let's fill this thing full of water. And then it sags. And when it sags, the laps come apart. And they go, Craig, you got a terrible flashing. I do not. What the engineers always tell you, that flashing has to be supported all the way to the backer wall. You take your drip edge and bring it all the way to the backer wall. We want this to be fully supported. It has to be fully supported. We don't want that 1/4 inch gap, anything greater than the 1/4 of an inch. So, puncture resistance, we have to be careful that nobody walks on this. 80 PSI with a rock under your boot is pretty easy to pop holes in it. So we want this to be protected as much as possible. Try not to hit it with anything. I knew my life was going in a seriously odd direction when my kids were young, and this was probably 10, 12 years ago, and they go, Dad, have you seen the new iPhone 3? Like, who cares about that? Have you seen exterior gyp? This stuff's incredible. They took gypsum and they put it outside, and it doesn't bother it. They have gypsum outside. This is wild, right? So it took me a little while to figure it out, and I went to some friends at the Yellowboard company, and I said, how in the world did you do it? They go, oh, well, we coated the face of it with silicone. And remember, it was an air barrier when it first came out? Does anyone remember that? For the first 9 months, it was an air barrier. And they said, all you have to do is take peel and stick tape and put it over all the joints. And then after 9 months, we have no recommendations. You already got it. Why did they stop? Because the next morning, all of this would be lying on the ground. It was silicone. We basically put it on the release liner. And we hoped that it would work. These are good, smart people. 1 and 1 equaled 4 in this case. So what do they want now? We have to prime it. Actually, Laverne stated one day, if it's on exterior gyp, you're supposed to prime it twice because it sucks it in so much. This will stick to exterior gyp if we prime it. Also, if you happen to be on a job site that just may be dusty, damp, or dirty. Anybody been to that one? Is every job site in the history of construction dusty, damp, or dirty? You're supposed to prime it. Why do we ask that? This is supposed to be up forever, right? For the length of your wall, life of your wall. It has 5 PSI for peel adhesion. Know what else has 5 PSI peel adhesion? Post-it note. So with primer, we can get upwards of 15 PSI. It's supposed to be on that wall for the life of the wall. Well, let's prime it. The scary part is, I know a brick distributor. They're a pretty big brick distributor. They're all the way through Ohio, all the way into Maryland. And 17 locations. Anyone want to guess How many pails of primer they sold last year? 35. They sold more truckloads of peel and stick than they sold pails of primer. Just putting it out there, folks. We have to insist that it's done correctly if we want to give this a fighting chance to win. Termination bars. I'm going to talk about termination bars more deeply. Brian, thank you for giving me the chance today. Termination bars, they go at the top. No, oh, laugh all you want. I went to Atlanta to the school systems. They said, hey, could you help me open up some walls and see what's going on? Here's the termination bar. It said install termination bars. And it peeled off the wall. And it did this. And all the water came down the wall. And we had a funnel to the inside. There's a lot of manufacturers who will tell you with through-wall flashing, just put a bead of sealant over the top. I want you to give them the one-finger salute. It's okay as an air barrier. It is okay as an air barrier. This is bent in an L. The wall's moving one way, the facade's moving another. You got a whole bunch of differential movement going. We want to mechanically fasten that top. We want to hold it there and make sure it is stuck there. We got that differential movement, okay? So it's very, very important that we do that. Anybody disagree with that? I'm a belt and suspenders person, but that one is about as simple as it gets. If we don't put the termination bar there, who here has seen duct tape that's been up for 20 years? Anyone? Duct tape, 20 years. Anyone? Sticky stuff that stick to the wall for 20 years. The duct tape has much better adhesive than this, by the way. We need to make sure we protect it. Let's put a termination bar, mechanically fasten it, and take care of it. It's UV sensitive, which means that we shouldn't leave it out in the sun for a long time. Anybody been to the job site where the flashing's been sitting out there for 6 months? Yes, yeah, I got a few laughs. Polyethylene. It's not good for the marriage to do this test, so I'm just going to give you the results. Take a piece of plastic, and I took a piece of the polyethylene that we use, and you put it on the back porch May 1st. May 30th, still looks like a piece of plastic and somebody's getting angry at you. The end of June, more anger, but the plastic looks about the same. The end of August, it's a little yellowed. And it's not as malleable, it's a little brittle. Every day we leave it in the sun, we're taking weeks, months, years off the performance life of this product. This product can be installed right before the wall goes up. There's no reason to have this sitting out in the sun for all of that time. Please protect your flashing because it has to work for a very long time. Also, because it's UV sensitive, it can't make it out to the exterior. So we have to use a drip edge because your flashing always has to make it to the exterior. So drip edges can be copper or stainless steel. They're two of the most noble metals on the galvanic scale. So they do well with water and the alkalinity of mortar. You never use aluminum, you never use galvanized steel. They're two of the worst on the galvanic scale. So you always want a drip edge. Have any of you ever put your kickstand down on your bike on a hot summer day and it's sunk into the hot top? Asphalt softens at 84 degrees. Asphalt turns to a liquid between 160 and 180. Cooking shows, anyone watch cooking shows? I love to cook. Fantastic. Best pots and pans in the world are made out of stainless steel and copper. Why? They're superconductors of heat. They can get 80 degrees above ambient temperature. So say it's a wicked, wicked hot day in Maine, right? It's like 80. Well, it is. It's like 80. 80 plus 80, we're at 160. What's a hot day in Cleveland? Is it 90? Can you hit 100 in the summer? Yeah. Let's do 100 because the math's real easy. 100 plus 80, it's not your fault, it's asphalt. Asphalt at 180 degrees is a liquid. So I'm in Nashville, Tennessee a few years ago. Gentleman stands up, he goes, I'm the design principal of this architecture firm. We use that product and none of our buildings look like that. And this 70-year-old QA/QC guy gets up, he goes, every freaking one of our buildings looks like that. Every one of them. You need to get out in the field to go see this. So we have to get it right. What do we want to do? I'm not picking on this product. There's ways to make this product work. This is a picture from a brand new, it was open for 2 weeks, Marriott Hotel in the White Mountains of New Hampshire. Not a warm place, right? That's not Phoenix. That's not Dallas. That's the White Mountains of New Hampshire. So the only reason we have this picture, and I love to tell this story, is my technical manager, who I love to death, loves to have a beer. Okay, so this was right by the bar. So he's out there and he's like taking pictures, and I walk out to see him at the patio bar, and the manager's with him. And all I can hear is the manager going, "Well, what's wrong with that?" I hear, "Dude, that was your flashing. Okay, that was on the inside of your building. We had, you know," he goes, "Well, what do I do?" We go, "You got to cut it all off. You got to cut the black stuff off." Why? Anybody here been to PNC Park in Pittsburgh? It's a travesty, and not just that they traded all their best players away, but it's a travesty that all the black stuff, you have this beautiful light-colored porous stone. The flashing was held back 1/2 inch as per the directions. And for the last 5 years, every cleaning company out there has tried to clean the stadium, and it looks awful. It looks dirty. Your flashing made your building ugly. What do? We've convinced the IMI to now recommend 3/4 of an inch. Hold it back 3/4 of an inch. I personally recommend at least an inch. As long as your flashing is at least on the drip edge a full inch. And if you're bringing your drip edge all the way back to your backer wall, that's not an issue. But if we want to make sure our buildings don't look like this and don't look like this, we need to hold the product back. Folks, a lot of spray foam used in this area. Wonderful product. Wonderful product. One of the big things that I love about the ABAA, we train folks. Trained contractors are super duper important. So in this particular case, they took a PVC key, they ran it down the wall. Then they ran it out and wanted to run it down the face of the foam. This was in Vermont. I got the call and they said, "Why are there all these holes in the flashing?" They sprayed 2 inches. You're supposed to put a light flash coat on your flashing, but they sprayed 2 inches. That 2 inches, according to the manufacturer, could be anywhere from 200 to 300 degrees, the exothermic reaction. It's a good flashing. It's a terrific insulation and air barrier. But some cannot deal with the heat. Has anybody in the crowd ever put saran wrap on a hot brownie pan? Usually it'd be in this crowd. Yep, thank you, because sometimes I feel all by myself, like I've done it multiple times. You put the saran wrap on, it goes, you go, damn, there goes my brownies. What do you think's happening when we hit this? Spray foam sets up the cells in closed cell spray foam set up at 212 degrees. What do you think this is looking at, like at 212 degrees? We have to protect it. That's why we want a very quick flash coat on this. That's why you want trained installers. And if you even have a doubt about it, use a better flashing. Use a flashing that doesn't degrade in the heat. Okay? Any questions on that? Flexible coppers. So we have some people in the room who are very similar to me. I like to call it seasoned, which just means a little bit older and a little bit less hair. And I feel older every day, especially when I can't get products out of the package. There we go. So, copper fabric flashing. Back in the 1930s, you had 2 options. You had sheet metal or you had nothing. So they said, why don't we take a copper, a dead soft copper, something you could bend, you could fold it right on site. Pretty cool, huh? You fold it right on site, they go, ooh, that's not very good because it punctures at 200 PSI. The last stuff we were talking about was 80. They said, there's no way that's good enough, so let's put a scrim on it. So they put back then it was cotton, nowadays it's fiberglass. They put a scrim on it, raised it up to 390 PSI for puncture resistance. Pretty cool. So they used the best sealant in the world, 1935, that's asphalt. And they built copper fabric flashing. So they made it, they rolled it up, they sent it off to the first job. What do you think happened? It was warm out. They sent a giant Tootsie Roll that nobody could unroll because the asphalt. So they covered it with this stuff that's all over my hands now. And why, if anybody comes up to see it later, please don't touch it. This stuff's called mica dust. Looks like glitter. It's a bond breaker. And it doesn't come off very well. And it's a bear to work with. But it's a phenomenal product. It has been a phenomenal product since 1935. Why? J.B. Callahan, great engineering firm out of Philadelphia, called me up. They go, Craig, we just cut copper fabric out of a building. And there's a flashing guy. You're like, ooh, how come? Well, the building was built in 1941. It was 5-ounce copper when it went in. We cleaned it all off. We measured it. It's 5-ounce copper now. Copper's a monumental metal. It doesn't go away. So that made this a great product. The problem is there's not an air barrier company out there that will let you use this product. How do you seal to it? How do you connect to it? It's a dirty working surface. Even the house wraps, they go to tape to it. It doesn't stick. Spray foam, you spray the foam on. I had a guy from this area call me up one day. He goes, yeah, the black stuff, I sprayed it on and it all fell off. Like, yep, it's going to continue to all fall off too. It doesn't stick to it. We have a bond breaker there. And if you're putting styrofoam, not styrofoam, I can't say brand names. So, sorry about that, polystyrene, either pink board or blue board in the wall, you're going to have issues with this because the only thing you can seal this with is flashing mastic. Now, flashing mastic is 20 to 30% solvents because what you needed was something that was strong enough to sort of melt this all together. That same flashing mastic sold on jobs every day today. How the VOC laws haven't caught up with them is beyond me. But what do the pink board and blue board companies say? No solvents, no aromatic hydrocarbons. I had to look that one up. I'm like, oh, solvents. Why didn't they just say solvents? No aromatic hydrocarbons. Who here has poured gas in a foam cup? Yeah, this is a good crowd. Kids, if you haven't poured gas in a foam cup yet, what you need to do is go home, go to Dunkin' Donuts, get a foam cup. You pour gas in it, and it just goes, shrivels right up. You throw a match on it, you have napalm. Well, it's true. Now, hold on, everybody. Who came here today thinking, man, I'm going to learn how to make napalm today? No. Hopefully nobody. And do not Google it, by the way. You're on the school thing. It'll be security here in seconds. So we had to move away from this. What happened? We went to non-asphaltic copper fabric. It's the same copper. It's the same great metal, same great material. But what folks did is everybody moved away from the fiberglass because it was like a window screen. And didn't really know that the window screen was a bad thing until you get to a job site one day and I'm watching a kid with a brick hammer just wailing away on the brick ties, knocking all the mortar off the brick ties. Anybody catching where this one's going? Flashing's at the bottom. Sharp mortar's falling down because the masons go, hey, yeah, that copper fabric always had little holes in it. Well, it didn't have little holes in it when it left the mill. But after you drop mortar from 4 stories high on it continuously. So by switching over to a polymer fabric, it took it to 780 psi for puncture resistance. Really cool. So it's compatible with all of the air barriers, sealants, insulations, color-coded. 3 ounces gray, 5 ounces red, 7 ounces is black. You're probably saying, why in the world would you make a red flashing? Well, the American Recovery and Reinvestment Act, everybody heard of it? The Obama money? Gave New York City, the school authority, enough money to tear down and rebuild 1,821 schools. Think about that. When they called and said, could you make it red? I said, I can make it polka dot, I can make it rainbow color. That many schools, I can make the flashing any color you want. So they wanted to be able to visually inspect it from the ground and know that they had the right flashing. And great product, but let's all be honest with each other, okay? Nobody has to save my feelings here. I say copper, what do you think? Expensive. My brother-in-law, how come you don't use copper? Expensive. Do you know how much it costs? No idea. I've never asked for a price. Like, okay. Copper was 60 to 80 cents a pound for 30 years. 30 years. Nice and constant. 2004, the commodities market finds it, takes it to $4.50 a pound. All of a sudden, people's gutters are being ripped off their houses, the electrical wire ripped off your jobs. So everybody goes, oh, copper's bad. No, copper's not bad. It's still a great product that literally lasts lifetimes. One of the things that we didn't like about the product is it needs to have this polymer scrim on both sides. Polyethylene burns. NFPA 285, this is a group who knows what NFPA 285 is. This is a Class B fire rated material because the polyethylene burns. We said, what can we do better? How can we make things better for the industry? So what we came out with was flexible stainless steel. And now all of these products have multiple competitors. All of my specs are non-proprietary. I list everybody in them, except for the hacks. There's a couple of hacks out there that you want nothing to do with, trust me. If you're not sure who they are, call me. My number's in the book, so please call me. So we originally took stainless steel that was the same thickness as the copper. It's like a clock spring. It was dangerous to work with. So we had to thin it down a little bit. It was wicked to work with. And as a guy who installs flashings, I don't like wicked hard stuff to work with. So we brought it down to 2 mils of stainless steel. 2,500 PSI for puncture resistance. 780, strongest one on the market. 2,500. So we didn't need to coat it on both sides. So what you get out of this is you clean stainless steel face. That clean stainless steel face is UV resistant, can be out in the sun, doesn't bother it. It's inert. Everything's compatible with it. That's super cool. You want that clean face for the compatibility. It doesn't burn. It melts at 2,700 degrees. This won't be on the test, but at 2,700 degrees, your building's having major issues that has nothing to do with your flashing. So, with that, it's also priced in the same range as the PVC keys, the plastics. It's much more affordable than the coppers. And it's really easy to use because it's very flexible and it doesn't take up a lot of space on your job site. So it's a neat product. If you're working anywhere like chemical plants or by the ocean, please use 316 stainless steel. 95% of what we sell is 304. That's a standard building grade of stainless steel. But 316, anything within 1,000 yards of the oceans, this is what we use on ocean boats. 316 stainless steel is a tremendous material. I'm going to ask a favor of all of you. Did you know that you can buy stainless steel in China? Polymer in China, glue in China, as long as you put it together here, made in the USA. That sucks. No, it really does. It sucks. Because Chinese stainless steel, one of my competitors uses Chinese stainless steel, so their mill found out who I was, and they sent me sample pieces, so pre-rusted stainless steel. Yeah, it was rusted. I'm like, this is their best one. And that's why the competitor covers both sides with poly, because he doesn't want you to see the rust. But what we ask of you is, the government figured it out, specify DFARS. Anything that you're specifying in stainless steel, specify DFARS stainless steel. And how did the government figure it out? When your stainless steel nuts on your helicopter blades started breaking off and flying away, they realized this is probably a really big issue. It has to be made. It doesn't have to be made in the US, it has to be made to US standards. So please, whatever you specify in stainless steel, get what you're paying for. Make sure it's DFARS stainless steel. Any questions on this? You can use a traditional stainless steel drip edge. No, any of the flexible flashings, folks, and the question was, can you use this as a drip edge? Sorry, because they can't hear you that well. Anything that's a flexible flashing cannot be a drip edge. Okay, you're going to get waviness. It's going to be a little sharp. Yeah. No, I had a guy in Texas, he kept rubbing it on his hand, and he goes, I cut myself. I'm like, oh, dear God. Yes, you did. You attach it with 2 beads of sealant. And your drip edge should also be sealed down.
So that's why you're not worrying
Right, well, there's no asphalt in there, so you're pretty cool. So has anybody here, thank you for the question, has anybody here ever worked on a project and you're so proud of it, right? You're so proud of it. We nailed it. And you bring it out, and the first person goes, you know what you should have done? Come on, are you kidding me? We went to one of those 3-letter engineering firms in Boston and said, what do you think of the flexible stainless steel? And I didn't realize that they would bring in 3 offices total over and then spend 2.5 hours telling me everything they hated about flashings, but it was one of the most enlightening days of my life. And what they said was, we want something that is malleable. We want something that sticks really, really well. We want butyl. And the reason they wanted butyl, they wanted a butyl lap tape to seal these 2 pieces together. And the reason being is currently, the way we do laps, oh boy. The way we do laps is we take a piece of flashing, we put 2 beads of sealant, we put another piece of flashing on top of it. Then we do something called putting heavy crap on it. We find a big heavy rock or CMU or a bucket, and then we keep unrolling it down the wall, and as we unroll it, it pulls and it comes apart because the sealant isn't dried. So they said what we want is here's 2 pieces of material. They said we want a lap tape that you cannot pull apart. So as you're pulling it down the wall, you can't get it apart. So what we did is, when this came out, in every roll, we had a piece of this lap tape that said, this is your lap tape, and a big sticker. Goes out to the first job in Chicago. Hey, Craig, customer service, could you talk to this contractor? He goes, yeah, man, we got the roll of the stuff that doesn't stick, and then we got this piece of the stuff that does stick. Man, that's cool. I can't use the adjective he used, but that's cool stuff. So can we just get the rolls of the stuff that sticks? Well, what we've done is we've had 30 years of training people how to use this. So what they wanted was self-adhering stainless steel. That butyl has 20 psi peel adhesion. It rips. I had one guy really pissed at me because he had yellow board and he put it too low and he could not get it off without ripping the face off the yellow board. And oh yeah, I should probably catch up on pictures here. So it gets used in a lot of different places. Parapets. You go over the top of your parapet, that way you don't have to worry about your roofing and your air barrier touching each other. You have an asphaltic air barrier, EPDM roof. It dries it in, you're not worried about UV, that sort of stuff. You're good there. Transition flashing. Has anybody ever had like a stucco wall? Coming into a metal wall, stucco always has their own air barrier behind it. They're not allowed to touch. Nope. Our air barrier cannot touch their air barrier. Well, what? Remember the pencil and the whole thing about not lifting your pencil as you do the building? You need transition membranes. So a lot of folks are using it as that. Lap tapes, sill pans, but very, very interesting product. In fact, it's the only product I've ever had that pretty much everybody I see tells me where to stick it. Thank you for laughing at the jokes, because as a flashing guy, it's not easy. You really have to work at some of these. I am going to get on my high horse here just for a second or two, if you don't mind. I think the industry's a little crazy in some ways. Sill pans have been around for a long time. We don't want to use them because you have to bend them out of sheet metal. You have to measure them. You have to send them off to a shop. You have to wait for them to come back. And they cost a lot of money, and we don't want to use it because it slows the job down. Where do walls leak? Doors and windows, where we cut holes in it. I mean, I'm bringing it right down to the basics. If we cut a hole in the wall, that's probably where it's going to leak. Then what do? We put pookie on it. And then we hope, right? We hope. Hope's a terrible flashing technique. It works for a while. But when we're hoping, when the water comes down to the base, it cannot go to the interior, we just solved the majority of the issues we have with windows and doors. The water has to go back out into the cavity. So very quickly about me, I coach football and I coach lacrosse. I like sports where little boys hit each other. Not sure why. I just enjoy those sports. And I have a lot of friends in the construction industry because I go down and I pick kids by email addresses of people in construction. Because the construction guy's kid is normally way tougher than the lawyer's kid. And the construction guy goes, hey, tell my kid to do this. Yeah, kick him in the butt. The lawyer's like, hey, we got to talk. And I'm out. So one of my friends, Josh, calls me up. He goes, look, I'm taking this old school. We're turning it into elderly housing facility. I have 14 sliders that need to go in. He goes, can you bend up pans for sliders? And I work with all the sheet metal houses, so I don't bend metal for contractors. So I said, you know what? How about I'll bring you a roll. I'll show you a guy how to do it. See if this works for you. Gave the guy a roll, gave him a picture of how to do it. Went in, got my vest, got my hard hat, signed in. Josh goes, all right, let's get out here. And he looks, he goes, I told you to do unit 13. He goes, I did 13, I'm gonna go to 14. He goes, what do you mean you did? He goes, no, I did what Craig said, pinch full turn, do this. It was pretty simple. He goes, Craig, we have to measure it. We have to fax it in. We have to verify all the dimensions. After we do that, we have to wait 2 weeks. Then when it comes in, do you know that sheet metal doesn't stretch? So if we measured it just a little bit wrong, we can't stretch it, nor does it shrink. So we have about 20% scrap factor. He goes, we hate this stuff. We fight it all the time. He goes, all right. He goes, my guy did it in 3 minutes. He goes, well, it's my first one. I'll do it faster. This is my first time I did it. And Josh says, okay, so 2-3 minutes. He goes, how much would an 8-footer cost? Because it costs $104 for sheet metal. I'm like, maybe $9, $8 full retail. He goes, why wouldn't, and he's fairly cheap. This is a guy who's like, why wouldn't we put it in every window and every door? We catch the water and put it, it's common sense, guys. Hopefully I'm not overstepping my bounds by saying it, but we can make the industry better if we put sill pans in. Active drainage planes. There's a bunch of different active drainage planes. Some of them have the netting on it, and what it is, the netting's on the flashing. Some of them have drainage fabric on it, and imagine a Nike dry fit shirt. It just wicks the water away. Used a lot in stone. You know, real stone, manufactured stone, thin brick, stucco, brick. Who here likes manufactured stone? Does anybody get the willies when you see manufactured stone? Because I went to the ICC and I looked and I'm like, guys, you're supposed to use a weep screed. But most people don't want to see a weep screed. They don't want to see the 6 inches above of concrete, right? So they run the stone right to the ground. So then there's no drainage. We want to have some fun. Run up to a subway and kick it. Kick the wall, and you'll see all the stones fall off. Well, it's fun, just don't stick around. They get a little pissy about it. If we leave the water in the wall and we give it no way to get out, we're in trouble. These all-in-ones are here to help the contractor install it faster, but that's a continuous sweep. It's an interesting product. Oh, is it sideways again? Dude, everybody, please do as I do, and sorry about that. But what you're going to see, you always want weep vents, you want airflow, but what you're going to see is that mortar course. You're going to see this will drain 2.5 gallons of water per 10-foot wall section per hour. That's like you have a pipe burst in your wall. Very, very neat product. It's one of those products that it's very interesting. Like you have the storefront at the head, if you're having issues getting weep vents in, that sort of stuff, this is a really cool sort of all-purpose flashing. What do I got left, Brian? 2 minutes?
I haven't given you that sign yet.
No, he holds 2 different finger up on each hand for me. It's never nice. Yeah, so rigid sheet metal. Everybody's familiar with rigid sheet metal. It has to be stainless steel. It has to be copper. Okay? Unless you go to the Pacific Northwest and they go, I use galvanized steel. Really? You use galvanized steel? Does it rust? Oh yeah, rust all over the side of the bill. God, seriously? And So rigid sheet metal is the best. It's also 20 to 30 times more expensive than doing copper fabric. Are you guys flush with tradespeople? You know the guys who know how to solder or weld? Just like you're kicking them off your doorstep because there's so many of them. I went to the 3 biggest masons in Pittsburgh and they all said, no, we don't do this. We want nothing to do with this. We don't have the tradespeople to do this. If you are going to use sheet metal like this, you need to solder it. Also, you need to make sure you don't do what they did. See how they attached it to the wall? I'm like, guys, beautiful job, wonderful material. What are you going to do? We're going to take peel and stick and we're going to put it over the top of it. This lasts 15 to 20 years. That lasts a couple hundred. We put bicycle tires on a Bugatti. We can't do that. We have to make sure that the accessories work. In this case, if you're using this material, please, 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 please tuck it into the back wall. Put it into a reglet. But it has to be mechanically into that wall because there is nothing that lasts longer than these materials. Why are there so many coppers and stainless steels? They're monumental metals. New York City's harbor, right? Statue of Liberty was put in July 4th, 1884. St. Louis Arch was put up in 1964 on its 50th anniversary. You know what they did to it? Full inspection. They washed it. It was dirty. That was it. The elevator, they could have fixed the elevator. It was a damn scary ride. But if you haven't gone, buckle up. So, accessories, real quick. My dad always told me a chain is only as strong as its weakest link. When I used to work with him, he'd say it all the time. And it's very true. No matter what flashing system, what air barrier system you have to get the accessories right. You have to do all the details right and get it done. I had no idea until my early 20s that my dad was talking about me. So what we did is we always tucked the flashing in the back wall. Great way to do it. As long as you're building with your scaffolding, you go up 10 feet with your backer wall, 10 feet up with your bricks. Does anybody do that anymore? Now that we have these huge lifts and we build buildings all the way up to the sky, and we leave the flashing at the base and we drop crap all over it. And we ruin it. What do we ask? Put sand. Fill it, the top of it with sand. Put plywood over it. Has anybody been to a job site and you see the flashing over every window and every door flapping in the wind? Has anybody here ever taken a piece of metal and bent it back and forth until it snaps? Yeah? If not, go to Home Depot or Lowe's this weekend. There's things called step flashing. You go in, just keep bending them until they throw you out of the store. It's very fun. It snaps. It's called metal fatigue. I go to job sites and they go, Craig, the flashing ripped. I'm like, no way. How could that happen? It's been flapping in the breeze for 6 months. Take a piece of 1x3, roll it up, a piece of strapping, tack it to the wall, protect your flashing, and do a thorough inspection. Do I recommend this way anymore? I love it because it's mechanical. It's tucked in that wall. I don't trust it anymore because it gets so damaged on the job site. Termination bars. Termination bars are a really good way to go. Termination bars allows you to put it in at the last second. Right before your wall goes up, you put your flashing in. So stainless steel is the recommendation. What do we see on most of the job sites in the country? Aluminum. Why? Because we use it on roofing. And roofing is a maintenance item. The facilities guy, when the termination bar goes bad, gets a cordless drill, takes it off, puts a new one in. Termination bar goes bad in your wall, you try to figure out why it's leaking here and rip all the flashing off around the building. Please, don't mess up your building by putting an aluminum termination bar. BIA says never, ever, ever put aluminum into a mortar type of wall. Anything that the alkalinity of mortar will eat it up. So there's plastic ones available also. Who here knows the hole spacing? 8 inches. Fantastic. Steel studs. 16 inches. So, I'm a guy, and I'm going to admit 2 things about guys. Number 1, we do guy things. Number 2, we don't read much, right? Well, Who here on Christmas hasn't left a bag of parts to your kid's toy? Right? We've done something like this before. We're going to figure it out. We're going to do it. We're good, right? So you have to tell them only on the steel studs. What happens when you put a screw into a wall, into a gypsum wall, and your pitcher's not the right height? So you jam it up or you pull it down, and don't you make me feel like I'm the only one who does this, right? So you wiggle it around, then it starts falling apart. You go, oh, that's bad, right? So you stop wiggling it. But here, we're threading it out. We're going zoop, and we thread it right out. And then, as the building moves a little bit, we create holes. So put a piece of blocking or a piece of metal strapping. In this case, that was at a university. They said, this is the only way we can get it because we can't get guys to stop filling in the holes. There's a hole, zip, there's a hole, zip. It's what we do. Termination clamp, we don't have time. Sealants, guys, a little secret about manufacturers. We're chickens. We're horrible, horrible chickens. Do you want to use flashing mastic to seal flashings? 20 to 30% solvents. So that means a year from now, you're going to have 70 to 80% of what you put in there, and it's going to be brittle as can be. Little movement in your building, your sealant's toast. Every flashing manufacturer says it's okay. Why? Because we don't want to lose the job to the next guy who says it's okay. And that sucks. I beg of you, don't be politically correct. Pick your sealant. There's a lot of great ones out there. Butyls, polyethers, high-grade silicones. Be picky. Okay? We can't get back at this. Get the best stuff you can possibly find. Lap joints, the less the better. Enough said on lap joints? More lap joints, the worse they are. We want to address lap joints. We need to seal them, use tapes on them, do everything we can, because when forensic guys open a wall up, they go, hey, where's the lap joint? They know. They know where it's leaking. It's at the lap joints. End dams and corners, very quickly. I was, when I first started, I went to the Charlotte-Mecklenburg school systems in North Carolina. And the old guy looks at me and goes, young man, not a mason in all North Carolina, know how to make proper end dam and corner. Like, translation, can I phone a friend? I have no idea what this man just said. But after 7 years in the field, there's not a mason in all of New England that knows how to make a proper end dam or corner. They're all available pre-formed. If you have folks who are trained, and the BACs and the IMI, those folks work with them to train them. You can only do it out of materials, out of the metals, because they're the only ones that are going to hold their shape. I dare anybody to fold an end dam for me. Pinch, fold, turn. I got a goopy pile of poo and a ball, right? And I'm pretty good at this. And what's going to happen is what happened in Alpharetta, Georgia, when it just unfolds. Remember, this can't span a gap greater than 1/4 of an inch. We're going to ask it to span the entire cavity as an end dam. It doesn't work. The manufacturers of this make preformed corners and end dams. If you have guys who are really good at it and they're making it with the metal, they can do the end dams, they can do the outside corners. They cannot do the outside corners without a lot of pookie. Pookie's not good. There we go. That's Matt. That's weep vents. Brian mentioned I may get arrested. Not for the reasons he will get arrested. Very different reasons. Every hotel I go to, I try to find the weep vents. It's a game. Hey, where are the weep vents? How far below grade are the weep vents? The mulch guy just keeps putting mulch on, and the weep vents are all below grade. Anybody here use weep tubes? Has anybody ever seen a weep tube that wasn't clogged? They're clogged before we finish the job. They're full of dirt. They're clogged. Has anybody used rope? You seen rope? I've seen a lot of nylon rope out there. Got a couple laughs. Nylon doesn't absorb water. Yet, I'm watching guys put nylon rope in buildings. It's supposed to be cotton rope. Why did we put cotton rope in buildings? We put it in there to make the weep hole, originally. And that's from the company being since 1935. That's originally, and then we just started leaving them in there. You have to put those every 16 inches. They don't drain that well. I beg of people to please use weep vents. The more airflow and water flow, the better we can get the water out of the wall, the better off we are. Does anyone see an issue with the weep vent? Too high. I didn't hear that. Yeah, well, we put weep vents. Well, they're supposed to be on top of the flashing. So in this one, because manufacturers, our fault, we make weep vents the height of brick. So we put a bed of mortar, and we have 4 inches, right? 2-inch air cavity and 2 inches of insulation to the backer wall, 3/8 high inch mortar joint. We just built a dam. We stress tested this building from day one. Tremco folks, please help me. Do you have a sealant that can be submerged for 100 years and still work? You're laughing like I'm saying something funny. We're building this. We need some help. Find that product. We can make a lot of money together because we're submerging our systems. We can't do that. We're supposed to have a slope bed, and we have to have the weep vent on the flashing. I know it sounds simple, but it's one of the things that drives me crazy. We make jumbo weep vents. Jumbos would go from the flashing all the way up to the next brick. Drip edge. Everybody familiar with drip edge? Remember when our grandparents built? They had ledges. Love ledges. They're not just for jumpers and pigeons. Ledges were to get water away from the building. Now we think a 1/4-inch drip edge is really going to get the water out there. Drip edges were originally supposed to be out an inch from the building. What happened on the first building? Everybody went, ooh, that's ugly. So we now just have this little drip edge hanging out of the building. Does anyone see anything wrong with this picture from the daycare that's being built next to my building? Does anyone want their child running by that? That's crazy. So IMI put a great article out in Construction Specifier magazine that if you have a UV sensitive flashing, that it has to have a drip edge. But what you can do at the base, because that's all grouted solid, you can basically take a flat piece of metal, put it in there. Drip edges always have to be sealed down. Please don't let anybody tell you that they don't have to be sealed down. They have to be sealed down. Wind-driven rain can get underneath them. So you can do that. Or with the metal flashings, you can go to the leading edge of the brick at the base level. Higher levels, if you're coming off a shelf angle and you have a caulk joint underneath it, we ask you, no matter what material, to have a drip edge. Because my favorite guy in the whole world is the facilities manager. He's going to go with his team and they're going to cut all the sealant out. And what they're going to do is cut all the flashing out. It's also the guy who caulks all the weep vents shut. You laugh, but we're not teaching them. It's our fault. It's the flashing guy's fault for not teaching them.